Hi everyone, Shiga here with Sir Dojo, and in today's video we're going to be delving into the difference between the binary number system and the decimal number system. Now, as it relates to the CompTIA exam, understand that notational systems are number systems, and a really simple definition for what a notational system is that it is a way in which numbers are represented. So let's go ahead and jump into that. Now, when it comes to the decimal system, this is what we are most familiar with because this is what we use in our daily life. This number system is one of the many examples of a positional number system. In a positional number system, a number is represented by a series of digits, each having an associated weight. For example, if I were to tell you that you have this number in your bank account, then almost innately you would know that this is 5,000. Now you know that this is 5,000 because you understand the decimal number system. So it's 5,000 when 5 is in the thousands place. Now let's go ahead and do a quick recap of the decimal number system. So this may not have been covered or taught to you the same exact way that I'm doing it here, but it's essentially the same thing. So I mentioned before that each number is associated with a particular weight. So that's going to be ones, tens, hundreds, thousands, and if you keep going left, you'll get eventually to millions, billions, and so on. So what we're looking at here is the decimal number system. So you know that this number is 1010 based on where each value lies in the number system. So as a quick recap, please remember that decimal is the human number system. It's the one that we're most familiar with. It is base 10, so it's 10 raised to a power. And the range or the values that you have in the decimal number system is 0 through 9. Again, hence 10 values. And with that said, let's go ahead and jump into the binary number system. Now, when we're talking about computers, digital electronics, or mathematics, what the computer actually uses at its core level is called the binary number system. Binary is base 2, which means that it only has two values, and those two values is either going to be a 0 or a 1. The reason for this is because computers are electrical. So if you think about electricity or a light switch, it's either going to be on or off, and representing this on or off impulse or this on or off sequence as a 1 or a 0. For example, when the processor is communicating with the memory, it is doing this in binary. I mentioned before that binary is the base 2 number system. And with that said, then we're going to be raising 2 to a power. So you start at 2 to the 0, 2 to the 1, and then you move left. Now, most times we're going to be doing either 4-bit binary or 8-bit binary. And we can represent this in a table of having 8 columns. So anything that you raise to the 0 power is going to be 1. And we are essentially doubling as we move left. So 2 squared is 4. So that is 2 times 2. Then 2 to the third power is 2 times 2 times 2. Right? So that's going to be 8. And if you double 8, which is 2 to the 4, then that's going to be 16. And again, you keep doubling as you go left. And this is essentially what the binary number system looks like. So very similar to decimal, but again, it's a different base, so it's going to look slightly different. So the only values that you can have, again, are a 0 representing off or 1, which means on. So this number right here is not 1010 because that would be a decimal number. This is 1010 because we're dealing with binary numbers. So you can use 10 in the lower right to represent a decimal number. So 1010 is a decimal number, but 1010 base 2 is a binary number. So I really do hope that makes sense. So decimal is what you're already familiar with. So if you use that as the baseline to understand binary, that will make it a lot easier. So decimal is the base 10 number system. You're raising 10 to a power. And the values for the decimal number system is 0 through 9. But when it comes to binary again, that's going to be base 2. and you're going to be representing those values in either a 0 or a 1. In today's video, we covered the differences between binary and decimal. So in a follow-up lesson, we'll be delving into hexadecimal and how that differs from these previous notational systems. If you appreciate the content, please give us a like, share, and subscribe. And if you have any feedback or questions, please go ahead and leave a comment.